Welcome to our journey through the fascinating world of quantum physics. You know, the science that governs the universe at the smaller scales where things aren't quite so intuitive. It's a world where energy isn't continuous but comes in discrete packets called quanta, where particles behave like waves and where cats can be both alive and dead at the same time. Well, at least in a thought experiment, that is. Today we'll meet some of the most influential quantum physicists, the rock stars of the quantum world, and explore their groundbreaking discoveries that revolutionized our understanding of the universe. Stay tuned for more quantum revelations. Let's start with a guy you've definitely heard of, Albert Einstein. Now, Einstein is best known for his theories of relativity, which describe the universe at the grandest scales. But what many people don't know is that he also played a pivotal role in the development of quantum theory. In 1905, the same year he published his groundbreaking paper on special relativity, Einstein also explained the photoelectric effect. This phenomenon, where light shining on a metal surface knocks electrons loose, had puzzled physicists for years. Einstein, however, saw it as evidence that light, which had always been thought of as a wave, could also behave like a stream of particles, what we now call photons. This radical idea earned Einstein the Nobel Prize in Physics in 1921 and laid one of the cornerstones of quantum theory. Ironically, despite his significant contributions to quantum mechanics, Einstein later became one of its most vocal critics. He famously opposed the probabilistic nature of quantum mechanics, saying God does not play dice with the universe. Next up, we have Max Planck, the father of quantum theory. In 1900, Planck was working on a problem that had been vexing physicists for decades, the blackbody radiation problem. Classical physics couldn't explain the observed spectrum of light emitted by a blackbody, an idealized object that absorbs all electromagnetic radiation. Planck cracked the code by introducing a revolutionary idea that energy is not emitted and absorbed continuously, but rather in discrete packets or quanta. He even provided a formula to calculate the energy of these quanta, which included a fundamental constant now known as Planck's constant. This marked the birth of quantum theory, a radical departure from classical physics. Chapter 3. Now let's talk about Erwin Schrödinger, the man who gave us Schrödinger's cat, one of the most famous thought experiments in all of physics. Schrödinger was a pioneer of wave mechanics, a formulation of quantum mechanics that describes the behavior of particles in terms of wave functions. He developed a wave equation that governs how these wave functions evolve over time, providing a powerful tool for predicting the behavior of quantum systems. But Schrödinger was also deeply troubled by the philosophical implications of quantum mechanics, particularly the idea that a quantum system exists in a superposition of states until it is measured. To illustrate this, he proposed his famous thought experiment involving a cat in a box. In this scenario, a cat is placed in a sealed box with a device that has a 50% chance of killing the cat within an hour. According to quantum mechanics, until we open the box, the cat exists in a superposition of states, both alive and dead at the same time. This thought experiment highlights the bizarre and counterintuitive nature of quantum mechanics and the measurement problem, which remains a topic of debate among physicists today. Chapter 4. Finally, we have Werner Heisenberg, another giant of quantum mechanics. Heisenberg is best known for his uncertainty principle, one of the most profound and mind-boggling concepts in all of science. In a nutshell, the Heisenberg uncertainty principle states that there are fundamental limits to what we can know about a particle's position and momentum at the same time. The more precisely we measure a particle's position, the less precisely we can know its momentum and vice versa. This isn't just a limitation of our measuring instruments, it's a fundamental principle of the universe. This inherent uncertainty isn't due to any shortcomings in our experiments, but is woven into the very fabric of reality, forever limiting our ability to know everything with perfect certainty. Heisenberg's uncertainty principle has profound implications for our understanding of the universe, suggesting that at its most fundamental level, it is inherently probabilistic, not deterministic. Outro. From Einstein's photons to Planck's quanta, from Schrödinger's cat to Heisenberg's uncertainty principle, these brilliant minds have shaped our understanding of the quantum world, a realm stranger than anything we could have imagined. Their discoveries have not only revolutionized physics, but have also led to countless technological innovations, from lasers and transistors to modern computers and medical imaging. And as we delve deeper into the mysteries of the quantum realm, we can be sure that even more wonders await us. Stay tuned for more exciting explorations into the mysteries of physics.